Dear chemistry aspirants, right now I have the equilibrium. Equilibrium unit 7 chapter will come. This chapter will come under chemistry and equilibrium when you studied in plus 2 level. Then this chapter will be faced by you, and here is the scanner and here is the context. What I am going to discuss, that is the chemical equilibria are important in numerous biological and environmental processes. For example, equilibria involving O2 molecules in the protein hemoglobin play a crucial role in the transport and delivery of O2 from our lungs to our muscles. Similar equilibria involving CO molecules and hemoglobin account for the toxicity of CO, carbon monoxide. When a liquid evaporates in a closed container, molecules with relatively higher kinetic energy escape the liquid surface into the vapor phase, and the number of liquid molecules from the vapor phase strike the liquid surface and R rate, and in the liquid phase it gives rise to a constant vapor pressure because of an equilibrium in which the number of molecules leaving the liquid equals and number returning to liquid from the vapor. We say that the system has reached equilibrium state at this stage. However, this is not static equilibrium, and there is a lot of activity at the boundary between the liquid and the vapor. Thus at equilibrium, the rate of evaporation is equal to the rate of condensation. It may be represented by H2O liquid, and it goes to H2O vaporization. The double half arrows indicate that the processes in both the direction are going on simultaneously. The mixture of reactants and products in the equilibrium state is called an equilibrium mixture. Double half arrow you can see simultaneously. Equilibrium can be established for both physical processes and chemical reactions. The reactions may be fast or slow depending on the experimental conditions and the nature of the reactants. When the reactants in a closed vessel at a particular temperature react to keep products, the concentrations of the reactants keep on decreasing while those of products keep on increasing for some time, after which there is no change in the concentrations of either of the reactants or products. This stage of the system is the dynamic equilibrium, and the rates of the forward and reverse reactions become equal. It is due to this dynamic equilibrium stage that there is no change in the concentrations of various species in the reaction mixture based on the extent to which the reactions proceed to reach the state of chemical equilibrium. These may be classified in three groups. Before going to this, objectives is here to identify dynamic nature of equilibrium involved in physical and chemical processes. So after studying this unit, you will be able to understand, explain characteristics of the equilibrium involved in physical and chemical processes. Many more is here, and I would like to ask you the reactions that proceed nearly to the completion and only negligible concentration of the reactants are left. In some cases, it may not be even possible to detect as experimentally the reactions in which only small amounts of product are formed. In most of the reactants remain unchanged at equilibrium state. The reactions in which concentrations of the reactants and products are comparable when the system is in equilibrium. The extent of reactants equilibrium varies, and the experimental conditions such as the concentration of reactants, temperature, etc. Optimization of the operation conditions is very important in industry and laboratory, so that equilibrium is favorable in the direction of the desired product. Some important aspects of the equilibrium involving physical and chemical processes are dealt in this unit, along with the equilibrium involving ions in the aqueous solutions, which is called the ionic equilibrium. So we will discuss in the next level of video, equilibrium in physical processes. We will meet in the next session. Till then, thank you, thanks a lot.